Generating large-scale 3D head avatars of non-existent identities is crucial for synthetic crowds, digital twins, and large asset libraries. In this work, we introduce MVC Head, a single-shot state space model that directly synthesizes high-fidelity and multi-view consistent 3D Gaussian head avatars. Current 3D Gaussian head avatar pipelines fall into three broad paradigms. First, optimization-based methods rely on dense multi-view studio captures from datasets like Nrsemble, often with 10 to the power of 4 frames per subject. They achieve strong multi-view consistency, but large-scale asset creation becomes slow, expensive, and requires dedicated rigs. Second, single-image to 3D GS pipelines first synthesize intermediate views and then fit a 3D model. They still need multi-view or 3D data, are bottlenecked by slow view generation, and their consistency is limited by how coherent intermediate views are. In this study, we instead build on a third paradigm, directly predicting 3D Gaussians in an end-to-end differentiable manner. This is fast, needs no studio and even no 3D data, and is naturally scalable for large asset libraries. However, existing methods in this setting suffer from poor multi-view consistency, mainly because they are trained on constrained 2D data. Fixing this MVC gap is the core challenge we address. Our goal is to synthesize high-fidelity, multi-view consistent 3D Gaussian head avatars in a minimal resource setting. We only assume access to large 2D face corpora, without multi-view captures or 3D data. This setting is practically important. Many studios cannot afford dense capture rigs. We also argue that enforcing MVC through intermediate view generation is expensive and fragile. Instead, we ask, can we induce MVC by design? First observation is that because most datasets normalize heads to be upright and centered, multi-view inconsistencies strongly align with image axes. Changing yaw mainly causes horizontal drift. Changing pitch yields vertical drift. This is where state space models are powerful. They can constrain information along scan directions. We therefore design a hierarchical bidirectional state scan, high bis, that sweeps along image axes, allowing appearance and geometric cues to propagate coherently, improving multi-view agreement. Even if intermediate generated views are inconsistent, self-renders from a single 3D model are, by construction, geometrically consistent. If we render the same 3D Gaussians from two different cameras, they always obey a valid SE3 transformation. We exploit this with a SE3 multi-view critic. We take the current 3D Gaussian head, render multiple self-views under known camera transforms, and feed both images and relative poses into this critic, which scores their cross-view consistency. We maximize this critic, effectively using self-renders as its own supervision signal for consistency. MVC head begins from a grid of randomly initialized learnable tokens. These tokens are progressively refined by hierarchical state space, HIS, blocks. At each hierarchy, the model predicts a set of 3D Gaussians. Unlike conventional 3D GS, here Gaussians play a dual role. They are not only the explicit 3D representation but also guide the refinement of subsequent HIS blocks. This coarse-to-fine design captures global head shape and fine details in a single forward pass. Each HIS block implements the high-bis scan. Intuitively, high-bis acts like an axis-aware scanning. Yaw-related changes propagate horizontally, while pitch-related changes propagate vertically, and both are reconciled in the latent state. This design directly targets the dominant failure modes of inconsistency. The synthesized Gaussians are passed to a 3D GS rasterizer, which renders views under randomly sampled camera poses. Because 3D GS is efficient, MVC head can afford to render multiple views per training step, which is essential for robust multi-view supervision while still remaining practical for large-scale training. These renders are evaluated by an adversarial texture discriminator and the proposed SE3 multi-view critic, which imposes MVC, supplying gradients that reward cross-view alignment of appearance and structure, thereby coupling geometry, appearance, and MVC without external multi-view supervision. Putting everything together, MVC head produces multi-view consistent 3D Gaussian head avatars in a single forward pass. It operates in a minimal resource regime, no multi-view datasets, 3D scans, dense capture rigs, yet delivers avatars that remain stable under large viewpoint change, making it attractive for large-scale asset generation, where speed, scalability, and privacy are all critical.
We also release FaceGS10K, the first large-scale dataset of ready-to-use 3D Gaussian head assets, independent of any parametric 3D head model, enabling training, benchmarking, and evaluation of 3D-aware head models. Although conditional generation is not the primary focus of this work, MVC Head is sufficiently structured to support personalized avatar synthesis while preserving multi-view consistency.